Chapter 13 centers on XML, which is Extensible Markup Language. Database functions as data sources for web applications. So generally speaking, whenever you have a web page, the information that's coming out of that page, unless it's truly trivial, is oftentimes coming out of a database. Sometimes these web applications use static HTML. You may have something that's XML or JSON. It's a self-describing document that lends itself to dynamic web pages. The chapter focus here is on XML data modeling and languages. Section 13.1 is about structured, semi-structured, and unstructured data. Structured data is stored in relational databases. It's something that is very rigid, has a predefined schema, and you are expecting things to be of a certain type and size. Semi-structured data is not all data has identical structure. Schema is information is mixed in, somewhat self-describing, typically some form of directed graph model. Unstructured data has little to no data type indication. Examples of that is just plain text, maybe a web page that's in simple HTML, but more likely think Facebook post or something, or Twitter tweet. This is an example of a semi-structured data as a graph. You have company projects. Underneath of that, you have various projects. Projects have names, numbers, locations, and so on, which are essentially attributes. HTML uses predefined tags. There's generally a document header, a script, functions, formatting styles, maybe it's including some styles and whatever it might be. Then there's a body, then there's which is typically made up of a set of tags. You may have table tags, various other types of tags, attributes associated with those tags, and a large number of predefined tags. XHTML extends the tags for different application and enforces the fact that the document must be a valid or well-formed XML document, meaning that all opening tags must have corresponding closing tags, or they must be done in line. Basic objects, an XML document has an element, it's simple, complex, or a schema document that defines element names and attributes. A document type, typically they're data-centric, document-centric, or hybrid. The conditions of an XML document being well formed: it begins with an XML declaration. There's a special tag that has to begin at the very beginning of the document. It is syntactically correct, and it is meaning that all of the opening tags have closing tags and so on. It adheres to the specification of XML, and that it is valid, meaning that it follows a schema if one is specified. The notation for specifying elements: element name star indicates an optional multi-valued repeating element. Element plus indicates a required multi-value repeating, so it must have at least one. A question mark indicates an optional single-valued, so it may have 0 or 1. And an element name indicates a required single-value non-repeating element. The notation for specifying elements: the type specification by parentheses followed by the element name. The exclamation @ list used to specify the attributes within the element. Parentheses can be nested when specifying elements. The bar symbol indicates either E1 or E2 can appear in the document. This is an example of a DTD, a document definition, essentially document type definition that is, or doc type basically definition, that it tells you what the schema is for, or the expectation of a document to be considered valid, that deals with projects and it looks like locations perhaps. XML schema language is somewhat similar, but it's implemented a little differently. Structure, it specifies the document structure, same syntax rules as XML documents. Elements, attributes, keys, references, and identifiers are included. And an example is 13.5 in the text. The XML namespace defines a set of commands that can be used, kind of like a scope, or similar to a namespace in coding the world. Annotations, documentation, and languages used. Elements and types: there's a root element followed by multiple first level elements, potentially multiple, and then specifying element type, min and max occurrences. Keys are constraints that correspond to relational databases. There's a primary and foreign key. You can have complex element types with XSD, complex type, and composite compound attributes. Section 13.4 is about storing and extracting XML documents from a database. Use the file system or DBMS to store documents as text. That's one choice. Use DBMS to store document contents as data elements. Design specified systems to store XML data, or create or publish custom XML documents for pre-existing relational databases. XML languages, query languages and standards include XPath and XQuery. Specifying XPath expressions in XML returns a sequence of items specifying certain patterns, values, elements, attributes. Qualifier conditions, separators, slash, double slash, those are going to control if you're looking underneath of one or looking through the entire document. XPath and XQuery are highly used if you do much with XML, so you can't really do it without using it. Here's an example of an XPath query for company.xml document located at company.com/info.xml. Returns the company root and all of the descendant nodes. Some examples of XPath expressions and XML documents that follow XML schema. File a company in figure 13.5. And this is basically the first one is there should be at the beginning a company element underneath of the second one is showing that the company element should have a department element underneath of it, or you want to retrieve that element. The third line basically says anywhere within that document there should be an employee element that, and you want it, and in particular you want it if there's an attribute on it called employee salary that is greater than 70,000. And when you find one of those, what you want back is their name. So it's essentially a way of doing a relatively complex query. The fourth one, similar concept, without essentially the wildcard search. You're saying within the company, give me the employee that is underneath of the company that has a salary grader, and I want their name. The difference could be if you had employee objects under someplace other than company. So maybe off of company you had contractor, and maybe contractor you had employee underneath of there. They would be differentiated, and you would find them in the third one, but not in the fourth one. The fifth line is basically saying, give me back the project worker who's worked more than 20 hours on pretty much any project. Whenever you're specifying queries in XML, you've got for, let, where, order, and by, and then return. And this is when you're using XQuery. The variables are preceded with a $sign for assigning variables to a range. Where specifies additional conditions. Order by specifies order of results, and return specifies elements for retrieval. Here's an example of XQuery in motion. Honestly, you're more likely to use XPath than you are XQuery, but it can occur. Generally speaking, though, you can do about the same stuff with an XPath expression. Other languages and protocols related to XML, you have extensible style sheet languages, XSL. You have extensible style sheet languages for transformations, XSLT. Web Service Description Language, WSDL, WSDL. You have Simple Object Access Protocols, SOAP, and you have Resource Description Framework, RDF. All of those, except for the very first one, are very popular today. The XSL kind of went away and was supplanted by XSLT, but otherwise, pretty much all of those are still in use today. Section 13.6 is about extracting XML documents from relational databases. XML uses a hierarchical tree sort of structure. A common database model is essentially a flat tabular sort of expression. So conceptually representing ER schema, the university example follows the choices of your root or course, student, or section. This is the ER schema for the diagram of a simplified university database. 13.9 is a subset of that university database is needed for an XML document. The hierarchy tree view of courses as the root, and a potential schema for the course as the root sort of representation. and then a hierarchical tree with student as the root. So the basic idea here that you're seeing is that when you're modeling something that's inherently relational or tabular and trying to do so in a hierarchical fashion, you have to pick something to be the order in which they're presented. So in this case, you're presenting it as student, section, course. In the previous examples, it was presented in a different way. So, but because of the nature of relational databases and the nature of XML, you're going to have to kind of pick one, and you have multiple ways of essentially serializing a relational database out to XML and vice versa. But it is not as seamless as you might like because of the nature. They're two different things. You're modeling two different types of data representations. One of them is essentially a tree. The other is a series of grids. This is the schema associated with student being the root. So you have student and then various items associated with hanging off of it, student that has at a element level name, SSN, class, type, and so on, and then a sequence of sections broken down. One of the interesting things that this is being modeled is showing the essentially an element nested underneath for SSN off of a student, whereas your alternative might be to do that as an attribute, not necessarily an element. So something to think of. The breaking cycles to convert graphs into trees, sometimes you have cyclic sort of representations. You're going to basically pick something to be the root and kind of hang it off of that, so to speak. Other steps for extracting XML documents from databases is to create an SQL query for extract desired information, execute the query, restructure from a flat to a tree structure, customize query to select a single or multiple objects into the document. There's also some database systems that support the concept of you simply add something like for XML and it'll do some of that work for you. So inside of XML SQL, SQL functions for creating XML data. There's XML element, which specifies a tag or an element name that will appear in the XML results. XML forest specifies multiple element names. XML ag is for aggregating several elements, and XML root specifies the XML document with a single root element. XML, SQL functions for creating XML data continued. XML attribute creates attributes for the element of the XML root. An example is to create an XML element containing employee, last name for the employee, and employee with SSN being done as an attribute, not so much. This is showing it in an element-wise sort of notation. It's an awful lot of space to store one character, right, or one name. So to store Smith is taking 10 or 11 bytes on each end, so 20 bytes, give or take. So that's one of the challenges with this sort of approach, and that's why we may go instead to doing it more as an attribute than as an element. To retrieve multiple columns for a single row, select XML element, name, employee, XML forest, and so on, and that returns the XML you see at the bottom of the screen. To create an XML document with last name and first name and salary of employees for department 4. And this is basically saying select XML root, XML element, name, depart 4, imps, XML aggregate, and so on. The result of that query would be something like this. So in summary, we've talked about structured, semi-structured, and unstructured data, very high level. Hierarchical data models of XML standards, the language for specifying structure, and the two that we talked about were XML DDTs and XML schemas. Of those, DDT is older, schema is more current. Approaches for storing XML documents, talked about sticking it in a column in the database, sticking it on a file system, and various other sort of approaches. XPath and XQuery, two ways of querying XML to retrieve values from it, and then mapping issues of how do you figure out how to convert from relational to XML structures. And then SQL XML allows for formatting query results as XML data. So various ways to do that depending upon the vendor. And with that, we've reached the end of the chapter. As always, if you have any questions with this material, do feel free to reach out to me. That's what I'm here for. Stay safe, and we'll speak again soon.